So good morning all of you dear TyBsc physics student. We want to consider in this lecture see the point of or chapter of the solid state physics, the crystalline state, and in this chapter we want to see here how to find the interplanetary distance or what is mean by the interplanetary distance. So that's shown by the interplanar distance which is spacing between the two parallel planes in the given system. So in this point we want to see here or to obtain the interplanar distance formula, and we have to consider here that the interplanar distance which is depends on the Miller indices of HKL belongs to the family of the plane of the Miller indices system, and which is considered here. So in the this figure, so consider as 3-axis system which is 3D space system. So consider in this figure, this is the O point, that is the center of this point. This is considered as the unit length of this unit cell which is considered as A, which is considered as B, and for example this is considered as the C. So consider in this figure this distance which is O to this point, for example consider as N. This is considered as the ON, which is the interplanar distance of the plane of the ABC. So this is A, B and C. So this plane, so that consider as in this figure, so that this ON which is considered as the interplanar distance which is considered as the small point or small d, so that is the interplanar distance d, and let alpha prime, beta prime and gamma prime, which is the angle between the x, y, z on the ON respectively. So this alpha prime, beta prime and gamma prime. So alpha prime, beta prime and gamma prime, which is angle between x, y, z axis, which is x, y, z axis. So this is the interplanar distance between this, or angle between this x, y, z axis, which is respect to this ON, which is the interplanar distance. So consider, for example, this OA, so consider this to this point. So this intercept of the plane of the ABC, so intercepts of ABC plane, intercept of this ABC plane which is considered as OA. So that OA is equal to A upon H. So A, which is considered as the side length of this, okay, this side length, this upon the Miller indices point is H, so that is A upon H. So in next point, so this is the length upon, which is length considered as the B on the y axis, so that consider as the point which is considered as OB. So this is considered this OB, which is distance, and that OB which is considered as B upon K, and next point, that is OC, which is considered as C upon L. So that is Miller indices in HKL system. So this interplanar distance or this distance which is considered as this A upon H for OB is equal to this B upon K, and this on Z axis, that distance which is considered as the C. So this is OC, which is considered as C upon L. So that is consider in this figure which is considered as this ON which is normal to this plane. So that ON which is normal to the plane of the ABC, so consider as the cos alpha prime, cos beta prime and cos gamma prime. So as ON is normal to the plane ABC, so consider here, so that of cos alpha prime, so that cos alpha prime which is considered as d upon OA, d upon OA. After that, cos of beta prime which is considered as d upon OB, and cos of gamma prime which is considered as d upon OC. So this is fine, and if we compare, this is, for example, this is equation number 1 and this is equation number 2, so that using this equation 1 and equation 2, using equation 1 and 2, so we get cos alpha prime is equal to dh upon a, dh upon a, because here consider as OA, what is this OA? OA is equal to a upon h. So we want to put here the OA, so that OA is equal to a upon h. So a upon h, that h which is going to for numerator side. Similarly, consider here cos of beta prime which is considered as d or b distance OB is equal to b upon k, so that b is coming from this denominator side and this k is going to upside, so that is the dk upon b, and this cos gamma prime which is considered as the dl upon c. So this relation which is come, and according to the law of the direction of the cosines, we want to square of this side and addition of this we get. So we want to write here, so according to the law of direction of cosine, according to law of direction of cosine, so that squaring of this both sides and addition, so that is, if we see here, so cos square alpha prime plus cos square beta prime plus cos square gamma prime which is get equal to 1. So this is the according to the law of the cosine. And if we see, so this is LHS side squaring, and if we get the RHS side squaring, so we get here d square h square upon a square plus d square k square upon b square plus d square l square upon c square which is equal to 1. This is according to the cosine law. Okay, so if we see here, so that d square which is common of this side, so this taken constant of the outside of this bracket, so d square constant, so remaining is h square divided by a square plus k square upon b square plus L square upon c square is equal to 1 is equal to 1. So next what happens here, so this d square is equal to h square upon a square, d square into h square upon a square, k square upon b square, L square upon c square. So what we want to calculate here, so that d square which is getting for this RHS side. So what happens here, so that 1 upon d square we get here, so h square upon a square plus k square upon b square plus L square upon c square. Okay, and we want to calculate here d, so that is considered as, so how it is decalculate, so that is the reciprocal of this side, so reciprocal of this side, so what is remaining of this, so that is we get here, so that is considered as d is equal to d is equal to 1 upon under root of this h square upon a square plus k square upon b square plus L square upon c square. Okay, so this formula we have to get cancel coming here. So according to this calculation, so what is the value of d which is coming here, this is the main formula, so that d is equal to 1 upon under root of h square upon a square plus k square upon b square plus L square upon c square. So this is the interplanar distance formula which is calculate. And if we have to see here the condition which is considered as, so this expression, so for example this 3 which is considered as the interplanar distance formula, interplanar distance formula. And if we consider here for the condition first, which is the cubic system, okay, and in cubic system already we have C condition there, so that both or 3 sides which is equal length, and alpha beta gamma, that alpha is equal to beta is equal to gamma is equal to 90 degree. So consider in the cubic system that have length that A is equal to B is equal to C, that is the all length which is the equal side. So that's why consider as here d square, which is d square into, for this formula, so that is h square upon a square plus k square upon b square, but all length which is similar, so that's why I consider as k square upon a square plus L square upon a square, which is equal to 1, which is equal to 1. So what happens here, that a square which is common for these 3 terms, so that why d square upon a square which is getting constant, so remaining h square plus k square plus L square is equal to 1. So this is remaining, and that get formula, so this a square is going to numerator for this side, and this h square plus k square plus L square which is get to numerator for this side. So that is given formula, that d square is equal to a square divided by this h square plus k square plus l square, and finally we get the value of the interplanar distance d of the Miller indices, which is considered as the HKL plane. So that d suffix HKL, which is given by a upon under root of h square plus k square plus l square. DHKL formula, that is a upon under root of h square plus k square plus l square. So this is for the cubic system. This is the interplanar distance formula for cubic system. Okay, now next formula, which is considered as the tetragonal system. So this is as the case number 2. Case number 2, which is system considered as tetragonal system, and in this tetragonal system, which is considered as two sides which is equal same length, and third side which is the different for this. So this above equation which is considered here, so that d square into h square upon a square plus k square upon b square plus l square upon c square. So what happens here, both side a and b which is same, so that getting formula which is considered as that d square into h square plus k square, both a and b which is same, so that's why we have considered here both are same, that is a square, so that is l square upon c square. Okay, so is equal to 1. So what happens here, so we want to calculate the d or interplanar distance of this plane. So consider here, so that we want to find that d square is equal to h square. So this side which is going to for this side, so that is a square divided by h square plus k square, and this which is considered as c square upon l square, and that interplanar distance formula DHKL, which is considered as a upon under root of h square plus k square plus c upon under root of l square, or write in terms of DHKL is equal to h square upon k square, h square plus k square divided by a square plus l square upon c square whole power minus 1 by 2, because of y which is, see here, so this terms which is this term which is the denominator of side of this, and which is comes in the under root of terms. So that's why we want to see that HKL is equal to h square plus k square upon a square plus l square upon c square whole power 1 by 2. And see the next point, which is the crystal direction and the planes. So consider this factor which is in terms of, so the crystal lattice plane which is the Miller indices of the crystal direction. Miller indices of the crystal direction considered as the plane system, and this plane system considered as, for example, in the two-dimensional space. So these are the lattice point which is oriented on the plane, and the figure which is considered as the direction of the Miller indices point. So how which is considered is here. So consider as in this two-dimensional space, so consider as the translational vector which is considered is here. So for example, this is considered as the middle point, and which is considered as the 3-axial unit, or which is considered as the 2-axial units or whatever, and the resultant point which is considered as the this. So this is the considered as the plane of this. So this is considered as 2-axis system or two-dimensional space. So for example, this is considered as the unit length which is considered as 2, this unit length which is considered as 3, and third axis which is the absent, so considered as the 0, so that's why we consider as this is considered as 2-3 plane, or the Miller indices of the crystal direction, which is denoted by vector r by the 2, 3, 0. So this is the idea. Next lecture we want to see here the idea about the simple cubic structure, body centered cubic structure, that is BCC, and information about the FCC structure, and what happens is there, what is the Miller indices point, how it is obtained the interplanar distance, so which is, or what is the atomic radius of the simple cubic system, FCC system, BCC system, which is seen in the next lecture. So thanking of you.